Today we'll be solving this LeetCode hard problem, minimum adjacent swaps for k consecutive ones. So the problem states that we are given an integer array nums and an integer k. Now nums is a binary array, means it comprises only of zeros and ones. Now in one move, I can choose any two adjacent indices and swap their values. Okay, so if it was 1 0, I can make it 0 1. Now I need to return the minimum number of moves required so that nums has k consecutive ones. Okay, and this nums length can go up to 1e5. Nums only consist of 0 and 1, and this k can be till maximum up till the length of nums. Okay, because the maximum sum of nums will be all ones, which will be simply the length of nums. Okay, so for example, if we have this as the given input, so k is 2, so we want two consecutive ones. So how we can make it? Either we can swap this one with this 0, or swap this one with this 0. So it will become 1 1 0, or it will become 0 1 1. So we'll be getting two consecutive ones after performing one swap, and hence the minimum number of operations required will be 1 in this case. Let's see another input. So we are given like 1 these zeros and 1 1. Now we want all the three ones to be together. So it will be the most optimal way to bring this one at this place. So how many swaps will need? It will be like simply the difference of the indices. So indices are 0, 1, 2, 3, 4, 5. So 5 minus 0 equals to 5. Hence we will need to move it 5 steps forward. Means 5 steps we will need to perform. So hence the number of operations required will be 5 here. Let's see another input. So we are given like 1 1 0 1, and we want two consecutive ones. So we see like we already have two consecutive ones, hence we do not need to perform any swap operations. Hence the minimum number of swap operations is simply 0 here. So one thing we know, like we definitely need to know the information about the position of ones. Okay, now once we have the position of ones, suppose one were present as these many positions, then I somehow need to, like suppose k was 3, I somehow need to group these k's first together, then try to like group them, then consider these k's, means continuous case, then these k's, right? So means at a time I like group k ones, and then like try to like bring them together in that particular group. Okay, now bringing them together is a second task. First we need to like group them on the basis of like k indices in the form of groups. So how we can do it? So we can simply like store the indices of each one in a separate vector, so that we can like means find out the indices of continuous ones using like a simple that vector only. So instead of like iterating through the nums, we can like simply find the one indices. We can create this vector of, and we can simply push all indices of ones, all indices of ones. Okay, now in this array we'll be considering subarrays of size k. Okay, so k size subarrays will be considering and moving it to the right at one step at a time. And at each step what we will do, for this current subarray that we have, we'll try to like it will have positions, suppose for this it will look like, so the subarrays will look like 0 1 2 3 4 5. So one indices will be 0 3 and 5. So for k equals to 2, first we will consider this. So for this segment, how many operations we require to put together these ones together. Okay, then we'll consider this subarray, means 3 to 5. Then we'll find out how many operations we need to make these ones appear together. Okay, so in this manner we can like try iterating through the entire array, and then we'll be able to like do this in big of n if we are able to calculate for a particular subarray what is the minimum of operations in like a big of log n or big of n or big of 1. Okay, because definitely we'll need to traverse through all the subarrays, but now we need to find out whether for a given subarray, how do we find out the number of operations required to bring all the ones together. So that is the task at hand here. So let's see the step-by-step approach for this problem. So the first step is to like transform it. So it will be simply like the problem asks us to, like if we have the subarray of k ones, okay, the indices are there, so we need to transform move these k1s such that they sit next to each other. That is, at indexes, suppose x plus 1, x plus 2, and so on till x plus k minus 1. Okay, so we want to move the k1s in such a manner. So we know like for each one this position is different. Okay, So hence, like calculating the distance to a moving target like this is like will be pretty difficult. So we want to like means change this problem statement into something which is simple, means which only deals with a like constant target. Okay, because here we have a moving target. So how we can like means transform our problem statement from this to something simpler. So that is the goal here. So we want to convert this into a standard meeting problem where like everyone moves to the same spot. Okay, so let's see the formula that we have for these k1s, and let's try to like modify it. So we have like let one indices of I be the current position of the ith one. Okay, and now we have a window of k1s to start at index x. So x, then x plus 1, then x plus 2 till x plus k minus 1. So we have like a current subarray of k1s, and now we want to means move the ones in such a manner that they are residing at these indices. Okay, so target positions of these ones would be x, x plus 1, x plus 2 till x plus k minus 1. So the formula will be like the cost of this will be what? It will be like simply the position that we have. Suppose it is I till suppose I plus k minus 1. So it will be what? Pos of I minus this x, right? Absolute difference. And similarly, pos of I plus 1 and minus x plus 1 and so on. So it will be simply what? The one indices of I minus x plus I, because for one indices of 0 minus x. Okay, the first one will be going to x and the second one will be going to x plus 1. So one indices of 1 and minus x plus 1, the absolute difference we are taking. Okay, so we'll do this for all the k values in the current subarray here. So let's try to like we see like currently we have this variable target here, but we see like this I and this I is common here. Okay, so maybe we can group them together, and that is what we most means do most of the times. Whenever we have a given formula, we try to bring it in the form of same variables and then try to like do some pre-computations or something. So let's bring them together. So the cost will be simply one indices of I minus x. Now if we simply create a separate array for this, okay, let's say call this adjusted indices of I, which will be one indices of I minus I, then a problem reduces to we'll have a new array where we want to solve the problem for from moving to consecutive positions. Initially we are moving to consecutive positions. Now we just simply need to move to this particular value x in this new array. Okay, so now we have modified the problem statement to be pretty simple. Initially the target was moving, now the target is fixed. Okay, so all the values will need to move at this particular space, at that particular space. So now we only need to move to a single position x, hence the problem has become pretty simple now. Now let's try to see how will be means what will be this most optimal x for any like case array length. Okay, so this is the problem at hand. So our goal is simply to find a value x that minimizes the distance to all points in the current window of adjusted indices. So this is the adjusted indices. Now we need to find this value x such that the distance of all points to this x in the current window is as minimum as possible. Now, so what will be this value of x? That is what we need to find. So the optimal meeting point, we have a subarray of adjacent indices. We need to pick a target value x that minimizes the total distance from all elements in this subarray to x. So you means seeing this problem statement, you might like get a hint of what this x can be. Like you can try to pause and think. So this x means simply means that if we have a set of data and we need to find a x such that it is the distance of all the points from this x, the sum of distances is minimized. So what will be that x? That x will simply be the median of that data set, right? So because we need to minimize the sum of distances, if it would have been like sum of square distances, then we will have taken the mean. I hope like the concept is clear. So for any set of numbers, the value x that minimizes the sum of value minus x is the median of that set. Okay, so hence for each subarray of size k, we'll be finding the median of that particular means subarray, and then once we have the median, we'll be considering that median as x, and hence we'll be taking the difference of all the values from this x from right as well as left, and then take the sum of it, and that will be the minimum number of operations required for this k-length array. Okay, so the problem simply boils down to we have a k-length array. So we have the indices from suppose I till mid, then till I plus k minus 1. Okay, so mid is denoting the like median index. Okay, and this is the this is the array of adjusted indices. Okay, so what do we want to find the sum of what, summation absolute of for values like which lies in the left, this mid will be greater, right? So summation what I equals to suppose j equals to I till j equals to mid, it will be what, it will be this suppose mid minus means adjusted indices of mid minus adj of what, adj of j. Okay, so for these values this value will be greater, so hence we want the difference like this, and plus for the right values, the values which lie on the right will be greater, so hence the difference will be something like j equals to mid plus 1 till j equals to I plus k minus 1. In this case what do you need, we will be simply needing adjusted of j minus adjusted of mid here. Okay, so hence we like means modified the problem statement into two parts, the left part which is smaller and the right part which is greater. Now this, let's try to solve it means separately here. So we want to find summation j, summation like I say mid adj of mid minus adj of I. Okay, and we see like this adj of mid is constant here, hence, and it will be occurring how many number of times, so it will be occurring the number of values, so it will be occurring mid minus I plus 1 number of times. Okay, so this will be, if this is x, then the sum becomes x into adj of mid, right, and minus summation j equals to I till mid adj of I. So we'll be able to get this in constant time. Now what do we want, we want the sum of a particular range, means sum of values from I till mid or in the adjacency array, in the adjusted indices array. So how we'll be able to get the sum in a means given range which where values are not changing, we'll be using prefix sum simply. So simple prefix sum will be working here, so we will be able to find this in like prefix of mid minus prefix of this I minus 1. Okay, so x into adjacency of mid, adjacent indices of mid minus this will be the final formula for the left count. Okay, and this x here will be simply mid minus I plus 1. So this left part is done. Now we need to find for the right part. So in the right part, what is constant here? So we see like again adjacency of mid is constant, but it is getting subtracted now. So the number of values will be simply I plus k minus 1 minus mid plus 1, or L to R, the number of values is simply R minus L plus 1. So it will be minus 1 plus 1, so I plus k minus mid. So I plus k minus mid, if this is the x, in this case it will be minus x into adjacency of mid, and it will be simply summation adjacency of g. And now again we need the sum from mid till what, I plus k minus 1, mean the range sum from this. So again we'll use the prefix sum, it will be simply what, prefix of I plus k minus 1 minus prefix of mid minus 1. Okay, so we'll be able to get this sum in this using prefix array. Again we'll be able to find the right sum as well, and the final the number of operations required will be like it will be like left sum plus right sum, and hence we'll like for the current k length window we'll be able to get it. Now we'll move this window one step forward and one step from the left, and then we'll be having means we'll be removing this value from our sum, and we'll be including this value, and then again find these values for the new range that we have. Okay, and at each for each subarray we'll be taking the minimum of these values. Okay, so this will be like the overall approach for this problem. The first step was to identify like we needed to move ones to the moving targets. Okay, but that would have been very complex here. Okay, hence we tried to rearrange the formula and bring it in the form of a constant target, and we saw like this I and I was common here, so we tried to create a new array adjacent indices where this. So now the problem was to simply this x was fixed now, so we'll be able to move to a single position x only. And now once we had done it, we tried to find out this x, and we saw like this x will be simply the median of the given array. Okay, so we'll find the median index will be simply what, the means the index which lies in L plus R by 2. Okay, so we can simply find this mid index by using this, and then we'll be calculating using prefix sums the required sum that we have, and yeah, will be done for each subarray. And for each subarray, we'll be maintaining a global minimum which maintains the minimum number of operations. So this will be like we know like we'll be traversing through the entire array using k-length window, and we'll be adjusting it. So this will be of the order of n, and we are using prefix sum, so inside every operation will be constant, so the overall complexity will be big of n only. So hence this will be like feasible for this problem, because n can go up to 1e5 only. So let's see the code to get more clarity about this problem. So we first create this one indices array. We'll like push all the indices which of one in this array. Now the edge case is if means there are no conditions on the number of keys means it will have. So if the number of ones that we have is simply less than k, then we'll never be able to satisfy this k consecutive ones, right? So in that case we'll simply return 1, or if we have k equals to 1, so in that case we'll simply return 0. Okay, so in both the cases we'll simply returning 0, because it is like either not possible or the means it is already satisfied. Okay, so in these cases we'll be simply returning 0. Now we find the adjacent indices of I array, which will be simply one indices of I minus I. Okay, now we need to find the prefix sum of this array so that we are able to calculate the sums of range in like constant time. So we'll calculate this prefix sum, prefix of I equals to prefix of I minus 1 plus array of I, and then maintain this global min subs which will be updating at each step for each array. So now we'll start from like we start from I equals to 0, so the start point will be I and the end point will be I plus k minus 1. So the mid will be what? Mid will be L plus R by 2. So it will be I plus k minus 1 by 2. Okay, so it will be like 2I plus k, which will be I plus k by 2. Okay, now once we have, we will be finding the median value which will be present at this mid index, which will be finding from the adjacent indices array. Now we want the part of both the sides. So which was like mid minus adj of I, and the right part was summation adj of I minus mid. Okay, so we are calculating for this was from I equals to means I to mid, and it was from mid plus 1 till I plus k minus 1, right? So we'll calculate these two values at each step. So the left part will be from indices I to mid, so the count left will be simply mid minus I plus 1. So we'll find out like if I is 0, then like this prefix of I minus 1 will not exist. So we are checking this so that sum of it will be till mid. Now we bring all the left elements up to median value, so it will be simply what the number of elements which will be using the same formula. This count left is this x that we used earlier, so x into median val minus sum left, and in this case it will be sum right minus this x into median val. So sum right minus count right into median val. Okay, so we'll be calculating the same way we did for the left, and in the end we'll be summing both of these ups and means finding out the minimum at each, and then return this minimum. So this will be the overall like approach for this problem. This runs for big of approximately of the order of n, and all the means this is also of the order of n, as well as this is also of the order of n. So the space as well as the time that we have used is of the order of n, and hence this will be accepted like it is big of 1e5, so it will be accepted within like limits of 1 second. So I hope like you were able to grasp the approach discussed in this problem. Let's try to submit the code as well and see like whether it gets accepted or not. Like I tried to keep it like keep the namings as well as everything like clear, so that like it means you are not confused like what it is denoting. So that's why like I have used big names. Means whenever you will try to solve it, you will like use simple names only, which you are able to understand. But for understanding purposes, the names have means generally being taken at like this. Okay, so it runs in 9ms, which is real fast. So yeah, this was the overall approach for this problem. And like whenever we want to find one thing that we learned new here was like this x, what was the optimal meeting point, the x, the median. Okay, so whenever we want to minimize the sum of absolute of values minus x for a given set of data points, then that value will be median. Another point was that whenever we have a moving target, we want to like make the target as fixed, then we try to means simply play with the formula. We have been doing these kind of things a lot of times. We have been playing with the formulas, trying to bring it in the form of single variable, and then do some pre-computations to store the result. So this, like, I hope like by now you have like learned this habit of like trying to write the formula on your own and then trying to manipulate it based on our like conditions. Okay, so once this is done, then we'll be simply like use prefix sums, normal prefix sums that we generally use to calculate the result. So I hope you were able to follow, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.